8C. So just some harder questions now on trig exact values and things like that, and related angles. So I have to find the exact value. So find the exact value of the following: sine squared 120 degrees cosec 270 minus cos squared 315 degrees sec of 180 degrees minus tan squared 225 times the cot of 315. Now there's a lot going on here, a lot. So so that equals, now I'm going to draw some little diagrams down here. Sine of 120 is that. 60 is my acute angle, right? Cosec of 270, I'm just going to do 270. Cosec's third letter is S, so it's like sine 1 over sine 270. So I can rewrite those as that if you want, but I don't have to. So 270, these are positive angles, remember. 90, 180, 270. If that's oh, no, what's wrong with me? 270 is all the way. So that one, if we're ever looking at sine 0, 90, 180, 270, 360, you don't draw this. You draw the following, the sine curve. I'll do the cosec curve in a minute. So that's 90, 180, 270, 360. So that's for our sine curve, for our cosec, but that's the sine curve, okay? So what have we got? Sine of 120, what's the sine of 120? It's the same as sine squared 60 times cosec of 270 is the same as 1 over sine of 270 minus cos squared 315, cos of 315, where does that sit? It's almost 360. The acute angle here is 45. So isn't that the same as cos of 45? All right, all stations to central. All stations to central. Cos is positive. I need the acute, so that's cos squared 45. Sec of 180 is the same as 1 over cos of 180. To do 1 over cos of 180, you draw the cos curve. You always draw the cos curve or sine curve for angles of 0, 90, 180, 270, 360, because if you try and draw the 4 quadrants, it sits on one of the edges, on one of the borders of the quadrants. All right, minus tan squared 225. So where's 225? Quadrant 3. 90, 180, 225. Quadrant 3 gives, that's got an acute angle of 45. So that's minus tan squared 45 degrees because tan is positive in quadrant 3. Cot of 315. Oh, we've got another 315. Here's one. I don't have to draw that one again. That's an acute angle of, so that's times 1 over tan of, what's the acute angle if you've got 315? 45. Is it positive or negative? All stations to central. It's negative. So that's what we've got. So we're just going to work them out. So notice how the diagrams help. All right. So sine squared 60. Sine of 60 is root 3 on 2. So this is 3/4 times 1 over sine 270. Sine 270 is -1, isn't it? So it's 1 over -1, which is just -1. Minus cos of 45 is 1 on root 2. Square that and you get a half. You're okay with just writing it as half? Times 1 over cos of 180. What's the cos of 180? That's my cos curve. That's -1 as well. Times 1 over -1. Minus tan squared 45. What's the tan of 45? 1. So that's 1 squared. Times 1 over negative tan 45 is -1. Let me put them in brackets so you don't mess it up. So isn't that just -3/4? What do we got? -3/4 plus, so it's minus -1/2, which is plus 1/2, minus -1, which is plus 1. 1 1/2 minus 3/4, that looks to be 3/4. Okay. In question obviously that's 0, 90, etc. I have to find the coordinates of point P. All right, when you see this 315, what do you immediately think? Acute angle is what? 45. And we know that if this is root 2 there, what's this length? No, if that's root 2, what's this length? All right, watch. No. If this is root 2, what's this length? Thank you. They're radii of circle, right? If this is root 2, that's a radius, radius, etc. This is root 2. Now, I'm going to draw up a right angle triangle because that's what we're going to have to do. Do you already see? Does anyone know the answer already? If I've got 45 here, don't I have 45 here? What sort of triangle is this? Isosceles. So I'm going to call this X and I'm going to call this X. It's an isosceles triangle. I've got 45 here. This has to be 45. That's how I know they're both X. Do you get it? That's a right angle. So because I've got this here, I should draw up a perpendicular to the X-axis. All right? I know you want, sorry, I shouldn't really call it X and X, but I'm calling them X and X because they're the same. I can call it L and L. It's because I've got a right angled isosceles triangle. So Pythagoras' theorem, x squared plus x squared is root 2 squared. Do you know what I'm doing? 2x squared is 2. X squared is 1. X is, well, for Pythag, you don't go plus or minus. Root 1, which is 1. In other words, my triangle is 1, 1, root 2. Okay? My triangle is 1, 1, 1, 1, root 2. So what's the coordinates of point P? So in other words, this length is 1 and so is that one. That's the only way you get a right angle triangle with a hypotenuse of root 2. So instead of putting it, so what I've got this is root 2 and this is unknown, those two side lengths. I'm not going to put X on the diagram. I think that's confusing you. Do you understand why that's 90 degrees? Because I've drawn a line up to the X-axis perpendicular to the X-axis. This is obviously an isosceles triangle. Okay. Oh, so what are the coordinates of P? It's 1, -1. So, okay, now, this angle called -120 because this is -120. We're not interested in that. That's not what we're interested in. We're interested in the angle, the acute angle with the positive, or not even with the positive x-axis, the acute angle with the x-axis. Now I've got 60 degrees. I'm going to draw up a right angle triangle. This must be 30 down here, obviously. Do you know the length of this? If that's 10, this is 10. The radius is 10 of the circle. So what's this? 10. I don't mind what you use. Obviously, I do not have equal side lengths this time. Does that make sense? I can't use tan. You know why? Because tan is opposite over adjacent. I could use sine and cos. All right. I'll call this one X and this one Y because they've definitely got different values. So let's just have a look. I'm going to do the cos of 60 is, oh no, all good, X on 10. Are we okay with that? Cos of 60 is adjacent over hypotenuse. Cos of 60 is a half, isn't it? So that's 0.5 equals X over 10. X is a half of 10, which is 5. And you know what? You don't have to find out the other side using trig. You could use Pythagoras' theorem if you wanted. So I know this is 5. Why don't we use Pythag for y? Y equals square root of 10 squared minus 5 squared. Or we know sine 60 is y on 10. You're going to have a, so what have we got? Or we could have done sine because it gives you the answer. Oh no, it's fine. Oh, this is better. What's that? Square root of 75, which is, you okay with this? Which is 3 root 5. Because that's the square root of 25 times the square root of 3. 5 root 3, sorry, not 3 root 5. 5 root 3. Yeah, just be careful. You know what? Motto of the story, do all your working out. You don't want to lose a mark for something that silly. And I just almost did. I was going to put 3 root 5 because I didn't want to write it out. Go. Here's the point P. How do you get there? Negative 5. Be careful. And 5 root 3. Negative. Oh. Yeah, see?
Moral of the story.
Too many morals today. The point, and how do you know? You go across and down. Back to the left. So this, even though that's 5 and that's 5 root 3, they're negative. So it's negative 5 root 3. Quadrant, find the angle theta. Find theta. 11C. I will do this one. We do 11D. Oh, no, we'll do 11D. Well, we've got root 13. No, we'll just do one of them, because then you can do some for homework. So we're doing C, 11C. So I've got 2 and 1 comma negative root 3. Find angle theta. Given that theta lies between 0 and 360, be careful. You can only find my acute angle here, but then you've got to give me the angle between 0 and 360. Can I just call this alpha so that we don't have any confusion? I want to call it alpha because they're saying find theta where theta lies between 0 and 360. Okay? So I'm going to draw a little right angle triangle over here. Let's just get the size of theta first, and then later we're going to work out whether it's how much it is. All right? So tell me how you get to this point. It's 1 and, yeah, but it's 1 and root 3 are the side lengths, and that is 2 because the radius is 2. You actually don't even need that radius 2, but you should be able to tell me already, because what's 1 squared plus root 3 squared is 4. Square root of 4 is 2. It works. And so what's this alpha? I don't mind what you use. Let's go tan of alpha, for example. You could have used anything. You could have used, so I've drawn up the right angle triangle. I know that is negative 3, but in side lengths it's root 3. Tan of alpha is root 3 on 1. What's alpha? It's 60 degrees. Actually, this question's easier than the other one. So in other words, this is 60 in here. What is the size of theta? Where theta... That's what theta is, girls. Got to be careful with this one. You know, where do angles, how do you measure angles? This is telling me I want it as a positive angle from 0 to 360. So therefore, what does theta equal? 360 minus 60, it's 300. Okay, be careful with that, because your angle is from 0 to 360. I don't just say it's 60. You've got to follow the rules and go anti-clockwise, starting from the positive x-axis to name a positive angle. This is, by telling you it's from 0 to 360, they're telling you it's a positive angle. You're going to see in the next lesson when they want answers as negative angles. I'll let you know, okay? I'm going to do something like the following. Simplify the following. I want the cosec of 180 plus a. Now, oh, no, I don't want that one. It's really question 15 I want to get to. So the cosec of 180 plus a. What does 180 plus a mean? It means draw it. That's what it means. 0. 90, 180. Isn't this positive direction? They're not negative angles. Go anti-clockwise. We've done ones like this. That's your 180. That's your a. So cosec is the reciprocal of sine. So that's the same as 1 over sine of 180 plus a. Now, what is the sine of 180 plus a? Negative sine a. So it's actually negative cosec a. Are you okay with that? Because I'm just writing 1 over sine so that you know, but I don't really need to write that. It's just, if it's 1 over sine, negative sine a, then it's negative cosec a. Now, question 15, these are the ones I really want to do. I'm going to do slightly different to what I've given you. I want you to simplify the following. Just going to do different ones to what's there. Tan of 90 plus theta. And I want to look at the cos of 90 minus theta, and then I'm going to look at the cos of 270 minus theta, and I'm still going to do some more apart from that. So the tan of 90 plus theta, girls, we've been looking at theta. If you know your 4 quadrants, you know what we've been doing so far. We've got theta, you should know these, 180 minus theta, 180 plus theta, 360 minus theta. We have never ever talked about 90 plus theta, never. And that is not the correct way that you're supposed to write your angles, all right? So tan of 90 plus theta, we can still draw it and we'll work out the related angle in a minute. So how do I do 90 plus theta? Doesn't it start from here? I've got 90. Which bit's theta? Is it up there or down here? It's up here. Now, if that bit up there, are you okay with that? This is 90 plus theta. If that bit up there is theta, remember, I'm not interested in the bit that touches the y-axis. I need the bit that touches the x-axis, which is down here. Remember? Butterfly, right? What's this? If that's 10, this is 80. If that's 20, this is 70. If that's theta, this is 90 minus theta. If this bit all here is 90 plus theta, then that's 90 minus theta. Because look, I've got 0, 90. If that's theta, remember with right angles, that's 90 minus theta. So I say, well, that, remember, I'm not interested in the angle touching the y-axis. I need the angle touching the x-axis. All right, all stations to central, positive or negative? Negative, definitely. Negative tan of the angle touching the x-axis, 90 minus theta. Oh, 90 minus theta. They want us to write it, simplify, as a ratio of theta. I don't want a ratio of 90 minus theta. This 90 minus, isn't that all got to do with complementary? What's tan's partner? Cot. So that's the same as negative cot theta. So the negative is because it's quadrant 2, all right? But tan of 90 minus, tangent, cotangent, complementary. Sine, cosine, complementary. Secant, cosecant, complementary. Go, 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 all right? Right, this one. Cos of 90 minus theta. We've never talked about 90 minus theta, only 180 minus, 180 plus, but where is 90 minus theta? Well, we start from the positive x-axis, and I travel 90 and come back theta. There's 90, but come back theta. This is 90 minus theta. Do you get that? This is 90, come back theta. Look, 90 minus theta. Oh, so therefore, sorry girls, so this is theta. You okay with that? Because I go 90 and I come back for negative theta. So that bit up there is theta. This bit here is 90 minus theta. Oh, it's there. What's wrong with me? Cos of 90 minus theta is just the same as complementary, cosine, sine, sine of theta. Now, we're going to be using this a lot in proofs later. All right, complementary stuff. But see, the 90 minus is all your complementary, not the 90 pluses. So if you see 90 minus, that's all great. That's complementary. But 90 plus, you have to draw it and fix it. All right? 270 minus, there's no complementary rule with that. Yes. Ooh. Of 270 minus theta. All right, 270. So let's travel 90, 180, 270 in the positive direction. Come back for theta. So notice how I'm drawing it. 270, this is my theta, minus theta. I don't have to write minus theta on it because it's going backwards, it's minus theta. Am I interested in this angle here? So if it's ever 90 and 270 with a theta, it's always going to be touching the y-axis because y-axis is at 90 and 270. Do you get it? But if the angles are 180 plus, 180 minus, you're always touching the x-axis, all right? I don't want this angle. What angle do I want? This one, 90 minus theta. So this is the same, all stations to central. Is it negative? negative cos of 90 minus theta. So all stations to central. All right, what's the cos of 90 minus? We stick the negative because there's a negative. Sine. Negative sine theta. Another idea, like this, 180 plus 90 minus theta, because 270 is 180 plus 90. So it's the cos of, instead of being 180 plus theta, and you know that this is now your new theta, this is your bit that goes beyond the 180. So this is like this, cos of 180, 90, 180 plus 90 minus theta. So this bit's the 90 minus theta. Very good. Great idea. Let's look at question 17. We're going to show that tan of 90 minus a times the sec of 180 plus a times the cos of 90 plus a equals 1. Okay, so we're going to have to work out what each one of them is. 90 minus a. I'm going to do a little drawing. 90 minus a. 90 minus a, that bit's a, this is 90 minus a. So the 90 minus a's aren't a problem. 180 plus isn't a problem either, is it? That's normal. 90 plus a is 90 plus a. That one's got to be fixed. We okay with that? That bit there would be a. 180 plus a isn't a problem, it's a normal angle. 180 plus a, that bit's a. All right, so what do we got? That's the same as tan of 90 minus a, which is, well, it is cot of a. I can just, well, I'll write it as the cot of a, tangent and cotangent, times, what's the sec? Isn't that 1 over cos? So that's 1 over cos of negative. All stations to central, cos is negative. 1 times 1 over negative cos a times cos of 90 plus a. Isn't that, I'm not interested in this angle, I'm interested in this one here. Cos is normal. Negative, I'm just going to go negative cos a for now. Cos of 90 plus a is quadrant 2. That's 90 plus a. That's the same as cos of 90 minus a. Thank you. Which is, cot of a times 1 over negative cos a times negative sine a. Look, this is actually leading into the next thing that we haven't done this year, but you did do it last year. Do you know what sine on cos is, girls? Tan. All right. Now we know that cot a is 1 over tan a times, and we know that sine a on cos a is tan a. Because it's negative sine a over negative cos a, which is tan, because sine on cos is tan. Do you remember that? We haven't done it this year, but we did do it last year. Notice that the tan of a is the sine of a over the cos of a. Okay, so that's 1 over tan a times tan a, which is 1. That's sort of leading into trig identities a bit. So simplify the following. 90 minus alpha, sine of 90 minus alpha times the sec of 90 plus. Now, let's just see, 90 minus is normal. That's just a complementary, remember. If you see 90 minus, complementary, what's that? This one. Cos. Cos of alpha. That one you don't have to draw it. A 90 minus is automatically a complementary angle. But 90 plus is here. 90 plus. That's the same as what? Yeah, so the acute angle in the quadrant is 90 minus. So this is from complementary times sec is 1 over cos. You don't have to write it as 1 over cos. It's going to be negative. Oh, yeah, we can go 1 over cos. Negative 1 over cos 90 minus alpha. Are we okay with that? You okay with that? Because it's all stations to central. Sec is 1 over cos, but we're in quadrant 2, so the cos is negative. I can put the negative up there or down there, it doesn't matter. So it's the cos of alpha times negative 1 over, what's this? Sine of alpha. Okay, now, because we know that tan theta is sine theta over cos theta, well, the reciprocal of that, cos theta over sine theta, isn't that the flipped version of tan, which is cot? So once you know that tan theta is sine theta on cos theta, we also know that cot theta, which is the reciprocal of tan, is cos theta on sine theta. Because we know that cot is 1 over tan. That's because cot is 1 over tan. In other words, it's the flip of tan, the reciprocal of tan. So that